welcome back my friends, my dear students. So, this is the 21st class and we have just very briefly considered what is the concept of end to start, end to finish, finish to start and finish to finish concepts based on which activities can be scheduled. Point 1. Point number 2, I also mentioned and I did highlight quite a number of times initially in the beginning and also in the last 20th lecture, that the concept of PERT and CPM are only based on end to start. That means, once basically the job A ends, then only job B can start. So, number of days duration is given there, and also important fact is that no looping is allowed. So, we will consider that in a very simple example. So, as such we were just going briefly through the concept of cost. So, it will be expanded later on in a more detailed problem. So, we must remember here that we are considering the end to start criteria. This is just a repetition to make it much more clear to you. For denoting the number of days between end to start and what is the duration between two jobs. If that has not been the case, then the incremental cost structure would have been much more difficult to find out, considering the just simple example which we considered in the end of 20th lecture. You can consider different hypothetical cases where we can use a combination of different depiction of duration of the jobs for an activity and a job or a set of work task, and the concept, as I mentioned, it can be end to end, end to start, start to end, start to start. For an end to end depiction, the number of days, it is only true that the total number of days for the project would change or would not change. We have to answer that. For end to start, start to end and start to start, the concept would similarly be implemented such that we can understand that the way of calculating the slack, way of calculating the critical path, what we are going to do is only specific to end to start concept. Remember here again, as I mentioned, when we are doing this very simple problem of that cost structure which was 440 in total. So, we would consider linear cost structure, that is an increase in the number of days has a linear increase in the total cost structure. There is no marginal rates are happening at the fixed rate. So, the total cost of the project can be considered to be varying linearly. Calculating the marginal cost function for the project is relatively easy if linear cost functions are there. If the cost structure of the activity job task varies non-linearly with the number of days, then you face a lot of problem, and depicting the marginal cost function for the project is quite difficult in order to conglomerate the overall cost structure. So, given the early and late start dates for any activities, considering end to start concept is true, which would be used for the calculations, we find the amount of slack for the activity job as given by this concept. So, as it is given, the total slack would be given by this concept by late start, LS is the late start minus early start, or it will be given by late finish minus early finish. So, these are the general formulas for the end to start concept out of those 4 concepts. So, thus the total slack for the part would simply be the addition of the slacks for the corresponding activities jobs. So, add them all up for all the paths accordingly, and the free slack, which is Fs, is S is the slack, not the start. So, remember that Ts which is there where I am pointing my finger, this one on the 248 slide. So, this is basically the total slack, and this and the 248 slide also the Fs which is there is the free slack. It has nothing to do with the start, while the concept of E end to start, E end to end was a different concept based on which we do the calculation. So, the free slack is the actual number of days which may have for us to use as a cushion in case of emergencies. Remember, we will always have the free slack being less than equal to the total slack, and there may be cases where an activity job can have total slack, but no free slack. So, and what it means that if that is true, and what it means if actually total slack, free slack, everything is 0, that will also make sense as we proceed with the problem. Based on our discussion, what we have been having from the last part of the 20th lecture and the initial few slides for the 21st lecture. So, we can indicate some of the rules for drawing the activity on arc concept. So, it can be implemented for the activity on node concept also, there is no change. So, the network should be connected without any cycle, this is just a repetition of the same thing which we considered. It should be unique start and finish events should be there. Event should be numbered, so that any activity, if finish event has a higher number than the start. So, if you start from the left, which is the start, the right would be the finish, and they basically go in a branch or a tree concept from the start to the finish. An activity may be represented by only one arc only. So, because this is the arc 1. So, obviously, if it is node 1, it will be correspondingly done. Two activities may not be identical, have identical start and finish events. So, if it is an activity on arc concept, the last bullet point would also be applicable in from the activity on node concept. So, this again what we considered, I am just highlighting with a different diagram, the end to end, end to start, start to end, start to start. So, this is again given diagram A, B, C, D are the same implication. This is end and finish words are interchangeably used. So, please bear with me. Finish to start, this x is the number of days. So, if I basically go into the right side diagram, it means there is a number of days between A ending and B starting. Start to start means x is the number of days, which means between the number of days where A starts and B starts, the x is the actual number of days. Similarly, if I go to finish or end to end, so it means that once A ends and when B ends, the number of days is given as it is implied. So, let me at least for this diagram try to make it much clear. So, this is the end and this is the end. So, this x is basically the finish to finish or end to end. Similarly, for if I go back to point B, start to start. So, this is starting of A and starting of B, x is there. If I go to finish, start to finish, so where A is starting and where B is ending. So, this is x is defined. So, for our case, PERT and CPM will only consider point A. That means, let me highlight it. So, we will only consider this for our discussion. Even though the concept of slacks and critical path can also be done for B, C, D. So, finish to start relationship, the activity B, I am just explaining it time and again in order to make you understand more clearly in the qualitative sense. The activity B may not start until x days after activity A has finished. By letting x equal to 0, the precedence relationship between B may start as soon as A is finished. So, these are important, like if x is 0, what implication it has for all the three different concepts. Start is basically SS, the activity B may not start until x day after start of activity A, and if x is 0, obviously it will have an implication. Similarly, for finish to finish, then activity B may not finish earlier than x days after activity A is finished. So, if x is 0, obviously it will have an implication, if at all x can be made 0. So, in many of the situations you will find out whether for finish to start or start to start, finish to finish and start to finish, x may not be 0 or cannot be taken as 0. Start to finish relationship, the activity B may not finish earlier than x days after activity A has started. So, in order to perform the forward scheduling or the forward pass method and the backward pass method, which I mentioned in the 20th lecture, we have to normalize the finish to start, finish to finish, start to finish relationship to the start to start relationship. So, they should be normalization should be done, such there is no confusion in how this are implemented. Corresponding to performing of back scheduling, we normalize the time relationship between finish to start, start to start, start to finish and finish to finish relationship. So, how do we do that? I will just implement that. Now, the rules for calculating the precedence relationship for all the 4 concepts. So, I will only consider one as a problem and highlight that people can utilize the same concepts using the normalization concept, which is placed in front of you in this slide number 253. So, for finish to start, if the total number of duration of days of A is given as D suffix A, duration for B is given as D suffix B, then for the forward concept it is dA plus x is basically the overall way when you calculate the forward pass method and the backward pass method. This you will use the formulas. How we will use the formulas, I am going to come to that within few minutes. So, please bear with me, but pay attention here. It is basically if it is, and similarly for the backward method it will be dB plus x, and it will you will calculate accordingly. So, in the forward method we go from left to right and do the calculations accordingly, and from the backward method we will come from the right to the left. So, and we do the calculations accordingly. For start to start, if the forward method will consider x as the number of days which is there between job A and B, and for backward method it will be the summation of dB, which D suffix B is the duration for B, plus x which is the number of days, minus dA which is the total number of days for A. It may not make immediate sense, but once I solve the problem you will understand. For forward to the finish to finish method, you will basically have, as you go from the left to the right, it will be now dA plus x, that means how much you have proceeded on to the right, and then minus dB to find out the forward concept starting and finishing of the jobs. And from the backward method you will basically consider x the delay which the number of days of gaps which is there between A and B, and proceed accordingly from the right to the left. Finally, for the last one which is start to finish, it will be number of days gap minus dB, which is D suffix B, which is the number of days required for job B, and you will continue doing it for job A, B, C, D accordingly from left to right. And if you are going from the backward method, it will be x minus dA, D suffix A is the duration for job A. So, how we use that we will consider now. The time relationship time interval, for example, number of days which is there between two jobs can both be the lower bound or the upper bound based on which you will do the calculation. So, what we are trying to utilize in the forward method and the backward method is trying to find out what is the earliest you can start the job and what is the latest you can finish the job, because based on that, if the earliest start and the latest start of a particular job, say for example, is the second day and the 8th day, and if the total duration of the job is 4 days, that means there would be some leeway between which you can change the overall job. So, let me use without the values, let me use a diagram to explain that. Say for example, so this one is the earliest the job can start, and this is the latest the job can end. Now, consider the job duration is like this. This block is what it denotes the total duration. Now, if I consider your job duration, then let me highlight it for better understanding. It means the starting of the job which is here can be shifted here. So, if this whole job comes there, I am trying to use the to scale, which means the starting comes here, this end point comes here. So, this means the total amount of such leeway which you have. On the similar lines, if this end coincides with this point, so consider this end is this and is same, and this starting is this starting, then again you will basically have a leeway. So, this considering that it has been drawn accurately, the number of days the slack or the cushion which you have here, which is star, and the star which is here is the cushion, would be of the same duration. The time relationship or time interval, for example, can be both a lower bound or an upper bound in the time that separates the start and finish of two next following activities based on which you will do the calculation. Furthermore, time points and time relationship can both be positive or negative depending on how we calculate the forward pass and the backward pass method. There are two approaches to assign time intervals to a network. One is basically time interval is a lower or the upper bound considering the activities or event times or activities, that is the time relationship is given, and interval can be also considered from the duration. So, rather than the start and the finish, I will only consider duration, duration mean x. So, rather than only considering when it starts and when it is finished, I only consider x, or rather than only consider an x, I will consider that when it starts or when it ends, or when it ends when it starts, depending on which way you proceed, from the forward, which is basically from left to right, or the backward, which is from right to left. So, PERT were originally conceived in the 1950s as a joint venture of US Navy and Booz Allen Hamilton for the Polaris missile rocket work. This technique has probabilistic estimation that it assigns likely probabilities to the range of estimates for each activity that reflects the uncertainty inherent in estimation process. So, PERT estimates recognize that for any activity duration there are three important estimates. If you remember T suffix B, T suffix O, T suffix M. So, one is the optimistic time, one is the most likely time, one is the pessimistic time, and based on that you do the calculation. We have already seen it will be basically optimistic plus pessimistic plus 4 times the mean time. So, all these things divided by 6, and I mentioned that what is the probability 1/6, 1/6 and 4/6. Now, logic for the assumption is based on the understanding that to achieve a probability distribution with 99% confidence interval, observation should lie within 3 standard deviation of the mean value. So, considering it is a not normal distribution, if it was normal distribution, then 3 sigma onto the right, 3 sigma onto the left, considering the normal distribution would basically cover about 99.97 percentage of the overall area. But that as it is not normal, not symmetric, hence this calculation has been utilized in order to consider 99% coverage of the total area. A spread of 6 standard deviation or 6 sigma from tail to tail is the probability distribution that accounts for about 99.7 percentage for possible activity duration alternatives. So, this is the beta distribution which I have been talking about, and if you look the distribution which is in front of you, it is not normal. So, technically if it was normal, I am trying my level best to draw it, it will be like this. So, hope I have been able to draw, but I will just erase that. So, this is the beta distribution. This value is basically the time estimate, which is as A, B or O, P, depending on whether you want to denote it by optimist time or pessimist time, and M is the mean time based on which you do your calculation. So, again the estimated time is given by this formula. The expected time is the optimistic time, M is the most likely time, B is the pessimist time, and we will use this for the calculation as well as for the average value and the variance. Remember, we can have multiple critical paths, that is important note, and multiple critical paths means that there are many activities which are very important. So, any crashing or any over estimation of the time duration for any of the activities would have a huge amount of consequence, both from the time perspective as well as for the scheduling perspective. So, then also the question arises, if there are many critical paths, so which activities job tasks should we concentrate on, so as to reduce the overall cost to the maximum possible extent. So, it may happen that there are 2 critical paths, but we may only concentrate on one of the critical paths, because the overall saving of trying to crash the job would be higher in one critical path, not for the other. So, depending on the what is the cost structure, what is the number of durations and such information which is there. So, definitely the easiest method to reduce the timing for a common activity job path would be which is common to both the critical paths. So, if it is not common, obviously you have to choose the path in such a way that if you say, for example, if you reduce one job A arbitrarily considered in critical the first path, then it may be possible that you have to consider job D and E in critical path 2 in order to have the same consequence for reducing the overall cost for the overall project. But in case if it is avoided, that is best. So, what we need to concentrate is that whether there are activities and jobs which will basically have a consequence for both the critical paths, considering there are 2 critical paths. So, that would basically help us to solve the problem in a much easier way. So, but there are methods by which we can find the best combination of the activities of the jobs and the tasks which are there in front of us. So, consider this diagram here. So, there are activities which is starting on the whole project is starting at 1, and then it goes from 1 to 2 and 1 to 3, then 3 goes to 3 to 5, 2 goes to 2 to 5. So, I am not drawn the table in order to understand say what is the precedence diagram concept which is there, which job or activity follows what. So, then 5 goes to 8, 3 goes to 6, 3 goes to 4, and so on and so forth till the last end, which is job number 9. So, the numbers which are given like 1 to 2 is 2, 2 to 5 is 5, 1 to 3 is 3, 3 to 5 is 4, these are the duration which you are considering. So, now we have not considered CPM, critical path method, not the critical path concept as such. We are considering the PERT. For PERT we have the average time. So, what is important to note that in the critical path the durations are given as it is, while in the PERT method the optimist and the pessimist time would be given, and we have to utilize the most likely time also, use that formula which is optimist plus pessimist plus 4 times the most likely, sum them up, divide by 6. So, that will be considered as the expected time for any activity and do the job. So, that expected time which I just mentioned in the calculation for the PERT is these values which are written here on the PPT slide, which is 262 in number. So, for the project illustrated above, we can reduce any one of the following. So, if I consider the activities, you can either reduce 8 or 9, which is the last one, or you can do any combination between 1, 2 and 1, 3, or say for example, the 4th bullet point 1, 2, 3, 5, 3, 6 and 3, 4. So, any combinations can be done. So, I am just giving you a sample set, but when you are trying to reduce the number of days for any activities, that activity would basically mean that you are trying to utilize some resources, but if resources are being utilized, then the total cost component or the increase in the total set of activities for the whole project should be considered in such a way for each and every of these set of activities which are there in front of you in slide number 263 would be such that the total cost implication of reduction in the cost is the highest. But reduction in the cost, you may be asking that if I crash the jobs, obviously there would be an increase in the cost. So, what I mean is that as you are decreasing the number of days, there would be increase in the cost, but I will consider that set of activities for which the reduction is highest in the sense that it has the negative impact on your total cost structure for the project. So, reduction means I am basically looking at the loss in the negative sense, which is positive. So, how you analyze the problem would depend that what is your main focus, is it time, is it scheduling, is it cost structure, whatever it is, but for the time being we are only considering the time component as important, because we need to find out the critical path and the critical time. We have briefly mentioned about early start, late start, early finish and late finish, but what do they actually mean? So, early start means it is the early possible time when an activity job can start, and early finish would be the early start plus the duration of the day. So, the duration of the job. So, it was D suffix A, D suffix B for the activities. So, it is basically T given here. Late start is the latest possible time when an activity job can start without pushing the project duration over and above the critical time duration. So, late finish would be the late start plus the duration of the job which we have in hand, which is T. So, in this diagram, which is simply one, you have basically 1 to 2, which is the duration is 14, 1 to 3 is 3, 2 to 3 to 4 is 3, and so on and so forth. So, these durations are given. So, relationship would be basically mean that if I early start of 1 is say for example 0. So, the time when 2 can basically start this job 2 to 4 is earliest would be 14 days has to be completed, then only basically 2 can start. So, it will be early start can be 14. So, if I am going from left to right, the forward pass method, I will do my calculations accordingly. If I am coming using the backward pass method, I will basically start from 6 and then 6 is the end node and basically do our calculations accordingly from the right to the left. So, the forward pass method calculation is being shown as simply as possible. So, activities are given, the first column or the left column, and T is the time duration, which you just saw in the last slide, which was the 265th slide. The durations are given 14, 3, 3, 7, 4, 3, 10. Now, let us translate using the forward pass method. If I consider activity 1, 2, earliest it can start at 0th time. So, early finish can be what? If it takes 14 days, so it will early finish 0 when it is when the clock starts ticking plus 14 number of days. So, early finish will be 14 here. If I consider 1 to 4, again the early start is 0, early finish is basically 0 where it can start plus the number of days, which is 3. Now, let us come to 2, 4 and 2, 3 collectively. Now, see, if you consider 2, 4 and 2, 3, the early start for the activities 2 to 4 or 2 to 3 would not be 3 because it will be 4, because the jobs, if you see the diagram, can only start after the end of the 14th day. So, the early start for 2, 4 and 2, 3 is not 3, but it will be 14. So, if it is 14, then the early finish for 2, 4 would be 14 plus 3, which is 17, and 2 to 3 would be 14 plus 7 is 21. Now, then if I go to basically activity 3 and 5. So, activity 3 and 5 can basically only start after 3 ends, which is the 21st day, 21st comes here, and the total number of durations which is there for 3, 5 is 4 days. So, 21 plus 4 is 25. If I go to basically activity 4, 5, so now let me go back where 4 is there. 4 is there is for 3 and 4 is there for 17 also. So, that means 1 to 4 early finish is 3 days, and for 2 to 4 early finish is basically 17 days. Now, if I use that, earliest it can start is only after 17 days is over. So, for activity 4, 5 it is 17 here when it can early start, number of days is 3. So, the total number of early finish can be 17 plus 3, which is 20. Now, if I come to 5, 6, I will find out where is 5 is ending. 5 is ending either on the 25th or the 20th. So, what we will consider, the earliest it can start is not 20, but 25, because it cannot start until unless the overall activity 3 and 5 is finished, because the number of difference is 5. 5 would be considered later on, how I will consider that. So, 5 can 5th and 6th can job activity can start after 25 days are over. The total number of duration is 10, hence 25 plus 10 is 35. So, what you are trying to do is that as you go from the forward pass method, you check the maximum duration, put that and add the number of days and proceed. So, in this way you complete the whole forward pass method, write the values for the diagram which is shown or whatever diagram which is there in front of you, and once that is done, your first step of the job of the forward pass method is over. So, with this I will end the 21st lecture. Starting the 22nd lecture, I will basically consider the concept of the backward pass method and show that how it can be utilized to calculate the slack, the critical path, and any delays which are there in the overall project which is there in front of us. Thank you. Have a nice day.